5 minutes. Ready? Okay, electric fields. So the symbol for electric field is a script letter E. An electric field is defined to be the amount of force acting or available per coulomb of charge. Good question. What does that mean? So here's the scenario. Imagine that we had something electrically charged, like a balloon. Make sense? That balloon has a certain amount of charge on it. Which means, what's the definition of a field?
A space where force can exist.
Good. Volume of space with a force at every point, right? With Fe at every point. We're talking about specifically electric stuff here, so I'll say with a Fe at every point. So around this balloon, there is a charge. There's you can imagine, and I think he does a great level, you kind of got this field around the balloon. These lines would show the direction of the field, because the field is telling us what the attraction would be for something placed in the field. So if I put a little Q in the field here, there's my little charge Q, it's either going to be attracted or repelled depending on the charge, right? For the case of an electric field, we need a definition. And the definition is that so it's called a test charge. That is, you're going to put this thing in the field to see how strong the field is. A test charge is always, without exception, by definition in fact, positive 1 coulomb. And you should say to me right now, wait, Butch.
1 coulomb can't happen.
Yeah, what? You can't have a 1 coulomb test charge. That makes no sense for 2 reasons. Number 1, you can't get 1 coulomb in one place. And number 2, if I did put 1 coulomb there, let's pretend I could do it somehow. I mean, its field would dominate, the rubbing my hair in a balloon, that's producing, 10 to the negative 7th of a coulomb of charge. Like, this would be dominant by a factor of, a billion times. And so it's kind of, don't try to imagine it as being real. The test charge has no field of its own. And you're thinking, this is a weird thing. Like this is so it's an imaginary test charge. But this actually, this is in most textbooks, the concept of test charge. You put a +1 coulomb test charge, and that allows you to calculate the field strength. But really, that's just cheating. Because look, we've already defined field. It's the amount of force per charge. And so, the field, force per charge, what's Fe equal to? What's the equation? Over R squared, but it's per coulomb of charge. So, the electric field is equal to...
Whoa.
Do we have to be able to derive the Fe equation?
You can't derive Fe. How is Fe discovered? Calculus 2 class ago. What did Coulomb do?
You just tried that.